Now let's look at a problem that deals with cost. So a fence is built to enclose a rectangular horse pasture. The material for the sides of the fence that run north is $50 per yard, and the material for the sides that run east are $30 per yard. What should the dimensions of the pasture be to maximize the area if the total cost of the fence is $31.50? Okay, so again, I'm going to go ahead and sketch a picture. The picture usually helps me with the equation for the perimeter, especially when it's not just a rectangle. So I'm going to call these sides y, these x. I just like y for vertical, x for horizontal. Okay. Then I'm going to look at what they're asking me to maximize so that I can write my derivative equation. Okay, so what should the dimensions of the pasture be to maximize the area? So I want my derivative equation to be the area. So again, that would just be length times width, so x times y. Okay, so I have two variables here. So that means I need a constant equation. Okay, so the constant they give us, it's not the $50 per yard and the $30 per yard. It is not a constant if it's like $50 per something. Okay, so the constant is the cost. Okay, so our constant equation will be for the cost. Okay, so when they give you the cost, what you do is you still take the perimeter. So the perimeter would be add up all these sides, so it would be 2x plus 2y. But then you take each part of the perimeter and multiply it by what it cost. So x, these are the ones that run horizontally, so the ones that run east. So the ones that run east are $30 per yard. So I'm going to multiply the 2x by 30. The ones that run north are 50, so I'm going to multiply the 2y part by 50. So this part right here would represent the total cost. So I'm just going to set it equal to what it actually costs, which is the $31.50. And then I'm just going to simplify this. So this will be 60x plus 100y. Okay. Now, once you've got your constant equation, you're going to solve it for one of the variables. Okay. It doesn't matter which one you solve for. I usually solve for the one that has a smaller coefficient. Okay, so I'm going to subtract the 100y, and then I'm going to divide everything by 60. So 3150 divided by 60, that's 52.5, minus 100 divided by 60, that's 1.6 repeating. So since that's not a pretty decimal, I'm going to leave it as a fraction. And so now that I have this equation, I'm going to take what x equals, come over to the derivative equation, plug it in for x. So that'll be 52.5 minus 5/3 y, and then times this y. And then I'm always going to distribute that y in. So that'll be 52.5y minus 5/3 y squared. Okay. Now we only have one variable and we've distributed, so now we're ready to take the derivative. So this is going to be a prime equals the derivative of 52.5y is just 52.5 minus, bring your exponent in front, so 5/3 times 2 is 10/3 y. Okay. Then after you take the derivative, you are always going to set it equal to 0 and solve for y. So I'm going to move the 10/3 y over, and then divide by 10/3. Make sure when you type this in on the calculator, I would just make a fraction and do 52.5 and then the 10/3 on the bottom. So that'll give you 15.75. If you're not going to type it in with the fraction using the alpha y equals 1, make sure you put the 10/3 in its own set of parentheses when you divide. Otherwise, your calculator is going to divide by 10 and then divide by 3. So when you're dividing with a fraction, I would just use the fraction button. Okay, so that's going to make y 15.75, and again, y represents this length. Okay, and our lengths on this one are in yards. Okay. Then once I find y, I'm going to come back to the constant equation. So it's like you go to the constant equation, plug it into the derivative, get the answer from the derivative equation, and then go back to the constant equation. So this will be 52.5 minus 5/3 times 15.75. That's going to give us the dimension for x. And so that'll be 26.25 yards. Okay. So then how I write my dimensions would just be 26.25 yards by 15.75. Now let's look at one more example that's a different type of shape. Okay. So a rectangular window is capped with a semicircle on top and bottom and has a perimeter of 16 feet. Find the radius of the circle if the area is to be maximized. So my picture this time is going to look different. Okay, so this is going to be a rectangle with half a circle on top and on bottom. Okay. So this is going to be y. Okay. Since we're talking about a circle, I'm going to label this with r for the radius, since this part of it is a circle. So it would make this entire bottom side 2r. So instead of, and you can stick with x, but I'm just calling it r since we're dealing with a circle and that has a radius. Okay. So what I'm maximizing is the area. So again, that's going to be my derivative equation. Okay. So the area of this figure, it's going to be the rectangle plus the circle. Okay. So the area of the rectangle, that's length times width, so that is 2r times y, plus area of a circle, that is pi r squared. Okay. If you're going to call this side like 2x or x, you would have to make sure that matches as well. And you'd always have to make sure whatever you call this side in the rectangle that you use half of it for your radius. That's why I usually just stick with r for the radius, 2r for the side length of the rectangle. Okay. So I can't take the derivative yet because this has two variables. It has r and y. So I need to write my constant equation. So the constant that they give us again is the perimeter. So that's going to be 16 equals the perimeter of this figure, which is going to be the distance all the way around. So it does not include these two in the perimeter. You're just bordering this part. Okay, so that's going to be 2y plus this perimeter of the circle, that's the circumference. So our circumference formula is just 2 pi r. Okay. And then from here, I'm going to solve for one of the variables, and this time I'm going to solve for y, because if I look at this equation, there's two r's, but only one y. It's always easier to solve for the variable that there's just one of. Okay. So what I'm going to do first is subtract 2 pi r, and then to solve for y, I'm going to divide everything by 2. So that'll be 8 minus pi r. Then I'm going to take this equation here, plug it in for y right there. So that's going to be 2r times 8 minus pi r plus pi r squared. Again, I'm going to go ahead and distribute that. So that'll be 16r minus 2 pi r times r is r squared. And this time I end up with like terms right here, so I'm going to go ahead and combine them. So that'll be 16r minus negative 2 plus that's 1 pi. That would just be minus pi r squared. And then I can take the derivative now that I've simplified. So that's going to be 16. This will just be minus 2 pi r. Set it equal to 0. And then solve. So move the 2 pi r over, and then divide by 2 pi. And again, I would type this in with a fraction on the calculator, or if you're going to use the divide sign, make sure you put the 2 pi in parentheses. And that is going to give us a radius of about 2.546 feet. And that's all we need on this one. They just said find the radius. They didn't ask us to find the height of the rectangle part, so we are done once we find the radius.